Welcome and hello. This is a support video in HEC-RAS, and in this video I'm going to be debugging by simplifying. Now when I'm building a model in HEC-RAS, I like to save regularly and test regularly. That way if I have a problem, I can just backtrack to the last time that I saved and ran the model successfully. However, if I'm sent a model from a user or you find yourself working on someone else's model and there's a problem, sometimes you don't have that option, and the best option is to simplify by deconstructing the model systematically, saving it, testing it, and then once you get the model to run, you can rebuild parts of the model that you disabled or deconstructed. That's what we're going to be doing here in this model. I was sent this model with there a few errors. So let's just go ahead and run it first. Run, and then unsteady flow analysis. Click on compute. Okay. So it ran. It looks like we have an error. It's a 2D solution went unstable. Let's go ahead and see what we're working with here. And before I even look at the model itself, I realize that we have one storage area connection with breach data and one is set to breach. So we can very easily disable this feature because perhaps it was the cause of the error, and it's also very easy to add back in. I'm going to click on options and then SA connection to breach. Here is the breach data for our SA 2D area connection. I'm just going to click the checkbox here, breach this structure. Now it won't breach because this breach may have been causing our problem. So I'm going to click OK and then go ahead and file, save plan. Now it says 0 set to breach. Let's go ahead and compute. Okay, so it looks like we still have a problem. Let's go ahead and close that. Instead of just disabling the breach, I'm going to go ahead and delete it entirely. So delete this breach. Okay, there really wasn't that much data here anyway, and rebuilding it won't be a problem. Now we have no message down here. I'm going to go ahead and save the plan and click on compute once again. Okay, so it looks like there's still some problems. Let's do something else now. I'm going to go ahead and check on the boundary conditions. So I'm going to go up to edit, unsteady flow data. And I noticed that in this boundary conditions tab, we have some unused boundary condition. This doesn't look like it needs to be here. Delete and OK. And then there's another boundary condition. This is normal depth. Okay, 0.5 seems absurdly steep for a slope. Let's just make it 1% instead of 50%. And then we have inflow. Okay, that looks fairly normal. Let's check out the plot. Let's leave that as it is and then click OK. I'm going to save these unsteady flow data right there. Okay, so we made a little simplification there. While I'm making these changes, I am taking notes so that I can go back and add that levee breach back in, re-enable the breach. Any changes I make with the hydrology or the timing, I can go ahead and change those back to original. What I'm trying to do at the moment is just get back to a model that runs successfully. Even though it may be far from what I started with, at least I have a working model that I can move forward with. Okay, so let's go ahead and run that once again. Compute. Okay, still having problems. There's lots of things we can still simplify here. Let's go ahead and take a look at our SA2D connection here in the model. It's right up here. And if I click on SA2D connection, I've noticed that we're backwards in our direction here. So it says it's from the downstream 2D flow area and it's going to the storage lake. But what I want to have happen is be from the lake, reach to the downstream 2D flow area. So I can go ahead and make that change. We can go say from the lake, and then click on SA2D connection, and we'll say it is to the downstream area. Okay, so let's close that up and then save our geometry. Boom. Now if I go ahead and run that, click on compute, it gives me this warning here. I thought this might happen. Basically, it noticed that I swapped the to and from, and one option here is to swap it back, which we know is not right, or we can reverse the centerline stationing here, which I think has to happen in RAS Mapper. So let's go ahead and open that up. Here's RAS Mapper. I'm going to go ahead and make edits to the SA2D connection. So edit, edit, go ahead and click edit. Okay, so it's selected. Tools, and then let's reverse the feature. Okay, oof, that's not a good sign. So I'm not sure if it reversed or not. Go ahead and select it again, and then viewpoints. Okay. Okay, well let's save the changes and see if that made a difference. See what this looks like. Okay, so we're still having problems. You know what? I'm just gonna remove the SA2D connection entirely. So to do that, I'll go ahead and right click, edit the geometry on the SA2D connection, do a single click here, and then delete. Boom, it's gone from the model. I'm going to toggle off the terrain as well. Looks like we have some results. We don't need to see that at the moment. Okay, let's stop making the edits, save them, and then run. So let's go ahead and click on compute. All right, looks good. Well, we have a successful model now. We've simplified quite a bit as we've removed the entire SA2D connection, not just the breach data. And now we can start moving forward by adding that SA2D connection back in the right direction this time by sketching left to right if you're facing in the downstream direction, and then adding in the breach and then all the other data. One more thing that I like to do when simplifying and identifying where in the model the problem is to go to the unsteady flow analysis dialog box and actually reduce the start and end date time. So for instance, instead of 3-day simulation, I could just make it a, say, 1-hour simulation. That way, if the error occurs on day 2 or 3, or really any time in the simulation after the first hour, it will be isolated, and then I can extend the time period, resave, retest to figure out when the problem is, not necessarily where the problem is. And then also this computation interval may want to be a little bit less than 30 minutes, especially for a dam breach simulation. All right, so anyway, we got a working model. The next step is to build back. I have notes on my screen, another monitor here where I've kept track of everything I need to do. And that's just one example of how to debug your model by simplifying in HEC RAS.